The Aris software is inbuilt in a Proteus. The icon of Aris is available on the top, which is in the red color. Just press Aris. Automatically components will be imported from schematic capture or the schematic circuit into the component tray of the PCB layout. Here you can see your list of your all components. Okay, so we have used U1. If you see the component mode, this U1 is your 7805, R1 is 330 ohm resistance, J1 J2 are the two connectors, D5 is a red LED, D1 to D4 are the diodes which are used for bridge rectifier, and C1 is a capacitor. Okay, after this what you have to do is you have to select this square box, the 2D graphics box mode, and from the bottom you have one drop down menu. From that drop down menu you have to select border edge, which is represented by yellow, and this is a border edge in which we are going to place our components for PCB layout design. In the Proteus you have a facility of auto placer. We are not going to use the auto placer because auto placer puts components on this border in the border edge randomly. So we will select components one by one and place those components as per our requirement. Okay, so first of all I will select connector 1, that is J1. So this is aligned horizontally. I will rotate it and make it vertical, and just click in the border edge so that the footprint of connector J1 will appear. Then we have the rectifier bridge rectifier. First component is a D1. I will put it onto in the border edge like this. Again I will select D2, then place D2, then press D3. Yes, D3 is automatically selected. You can just press and put this D3. D4 is also selected, so just put it onto in the border edge. Okay, then next component we are going to place is a voltage regulator 7805. It is vertical, so I will rotate it and make it horizontal and place it onto in the border edge. Next component that we are going to place is a C1, that is our 1000 microfarad capacitor. Positive terminal is shown here, so this is here. The next component that I am going to place is a resistance. Okay, you can even rotate the component as per your requirement by right clicking on the component. There is rotate facility after placing it into the border edge. Next component that I am going to place is a red LED. So you can see anode is on the upper side and cathode is on the lower side. Just click it into the border edge. Also it shows the connections by the green wires. The last component that we are going to place is connector J2. So last component is a connector J2, which can be used afterwards for the connecting circuit, to which we are going to supply a power. So the component placement part is over. After this you have to do one thing. As we are going to make a PCB layout, the track width is very important. If you are going to design the PCB layout manually, the track width should be large. So go into this track mode. Okay, so various track modes are given here: T8, T10. T8 means 8 millith, 10 millith, 12 millith, 15 millith, like this. The calculations here are in the millith. So if you want to edit your own width of a track, then go into this edit tab, and you can see here T15 is selected by default. T15 is very small. I think it is half of 1 millimeter. So 1 millimeter is, let us make at least 1 millimeter. 30th milli is, I think it is equal to 1 millimeter. So the track width which we are going to get is 1 millimeter. If it is made 30th, that means 30 millith. Then press OK. After that you can design the tracks manually also, and there is a facility to do the routing automatically. Before routing automatically, we will go into design rule manager. This tab is provided for certain settings. Here you can see pad to pad clearance at least 10 millith, pad to trace clearance 10 millith, trace to trace clearance 10 millith, graphic clearance 15 millith, and edge clearance 15 millith. So as we are going to design, if you are going to design this manually, then increase the pad to pad clearance to at least 15th, then pad to trace clearance 15th, and trace to trace clearance 15th. Okay, and these are the design rules which we have changed: pad to pad clearance to 15th, pad to trace clearance to 15th, and trace to trace clearance to 15th. Okay, so that minimum distance will be maintained between pad to pad, pad to trace, trace to trace, and graphic clearance. Next, what you have to do is, if you are going to design a single side PCB for your project, because single side PCB can be very easily designed manually. So what you have to do, you have to put all tracks onto the bottom side, and for doing that, go into the net classes, and you can see here net classes, and there is one drop down box, and from that drop down you have a signal, and here you can see a top copper. We are not going to use a top copper, we are going to design a layout using bottom copper only. So select, drop down this, and select bottom copper. This software is this software can be used for multiple layer designing, multi-layer designing. As we are designing single sided PCB, make pair 1 as a bottom copper and save it. Okay, then press OK. Now we will do the routing of a PCB. Here you can use automatic routing. Here is a auto router. Just press this auto router and press begin routing. So here you can see your tracks are ready. All these blue lines means what is your tracks are on the bottom side, and these blue components are on the top side. Okay, I think the track width is very small, so let us change it. Let us undo first. Go into edit and undo changes. Okay, go into track mode, edit, and make it 40, 45 will make it. Okay, then go to the auto routing and begin routing. So this is how your PCB layout is ready. Okay, if you want to see it in the 3D, the facilities available in the ARIS, you can have a 3D visualizer here. I will press the 3D visualizer button. So you can see this is a top side of your PCB. So this is a connector J1. To this J1 we are going to connect a transformer, and this is a connector J2 where we are going to connect a further circuitry to which we are going to supply this 5-volt regulated power. This is our IC. This is our IC 7805. This is a filter capacitor, 1000 microfarad capacitor. This is the indicator LED, and this is resistor R1, and this is our rectifier bridge. So let us close this. Okay, if you are going to design this PCB manually, then you need a printout of the layout. To get the printout of this layout, go into the output and print layout. Okay, then press OK. Okay, we are not using the top copper, we are not routed our tracks on the top copper, so deselect it. Yes, bottom copper is needed because on the bottom side the tracks are there. Remove the top silks also if you need the printout of the layout only. So I will remove the top silk also. Preferably you put this border is as it is, so that you will have the idea of a PCB size. So drag it at the center of a page, and your PCB layout is ready to print. Just print OK, and it will be printed onto the A4 size paper. So sir, okay, so many facilities are there in this software. You can even generate the bill of material. So here is a bill of material tab. Just press it, and you can see the bill of materials here. So one capacitor we have used, R1 we have used 7805. Transistors we have not used, so transistors will not be listed. Diodes and LED we have used. Connectors J1, J2 we have used. So in the proprietary editor you can place the cost of each and every component also. Okay, so to get the total cost of your components. So well friend, this is all about the PCB layout. If you like the video, then subscribe my channel. In the next channel we will see how to design the component and its footprints. Thank you very much.